All right, good afternoon, good morning, and welcome to the LoRa Alliance webinar with Senet and Neptune about evolution of smart water metering in North America. My name is Rémi Demerlet. I'm with Semtech in marketing for LoRa, and I'm the leader for the work group of utilities at the LoRa Alliance. Today, I'm happy to moderate this webinar where we invited Senet and Neptune. All three, we are members of the same LoRa Alliance. So let's begin with an introduction about the LoRa Alliance and especially the core of the IoT ecosystem that we are promoting, LoRaWAN. LoRa Alliance is a non-profit organization which plays a key role in the revolution of Internet of Things. We develop and maintain LoRaWAN, the open network protocol, which is used everywhere to connect devices to internet via LoRa radio technology for long range and low power data communication over unlicensed band spectrum. With more than 135 million of connected devices using the same radio and more than 137 LoRaWAN operators over the globe, LoRaWAN has become the leading technology for low power, wide area networks. Created 5 years ago with more than 500 members, the LoRa Alliance is one of the fastest growing ecosystems in the IoT. So connecting things here, as you can see, starts with electronics. The radio chips or the module that embed the LoRaWAN protocol stack are used as modem in devices to communicate data over networks operated with gateway and LoRa network server, either in public or private mode. Data can be collected then by application server and used with internet application. This is why LoRaWAN enables connectivity for the IoT. Let's see the vertical applications where LoRaWAN is used. Next slide, please. Yes, so many applications today are benefiting from LoRaWAN. This is the upside for a great flexibility enabled by an open network standard and one unique certification as specified by the LoRa Alliance. This ensures interoperability. So among the different verticals, energy and utilities stand as one of the larger in terms of number of connected devices with many assets, like typically water meters, we are going to speak, and also other devices that can deliver pressure, temperature, or be activated on demand. The requirements are very high in the industry of utilities because many of these assets are installed in harsh environments like water pits or underground and must stay alive for a very long lifetime, like 10 or more years. So far, long battery life and key challenges in network deployment are among the hardest challenges in IoT for radio transmission. And this is exactly why the LoRa radio was designed and made available by Semtech since 2012. Joining us to talk more about these advantages for smart water metering solutions and to understand how to design network deployments with LoRaWAN, it is my pleasure in welcoming Robert Gusting from Neptune. To introduce him, he is a senior product marketing manager at Neptune, and Dave Kendall, CTO at Senet, operator for LoRaWAN network in US. In our agenda, we will listen these gentlemen to deep dive into the topic of smart water metering in North America. Then you will learn how utilities in North America are pushing requirements in regard of smart metering and what are the key values of the proposal of Neptune with LoRaWAN. You will also get from Senet key points to design and deliver network as a service or to operate in different ways and to enable new application. So we will wait for the end of their speeches to enter into the Q&A session. So you can use the Q&A text box at the bottom of the webinar window to put your question. And just now, without further delay, Bob, I will pass the presentation over to you.
Remy, thank you very much. I appreciate it and want to welcome everybody to this afternoon's WebEx on behalf of Neptune and Senet. Again, I'm Bob Gustin, Senior Product Marketing Manager based here in Duluth, Georgia at our Innovations Center in Atlanta. Essentially, what I wanted to do was start for a short summary of highlighting Neptune and introducing Neptune perhaps to those of you that are not familiar with the company, and we'll start out with that very quickly. If you're not familiar with Neptune Technologies, based the headquarters in Tallahassee, Alabama, it's a technology company. It's been serving the water utility industry for about 120 years. So we certainly have been very stable in providing the needs of the water industry for certainly well over a century. We are a manufacturer of various different metrology and metering products, both positive displacement as well as ultrasonic technologies, the new static technology that hopefully many of you are actually evaluating and deploying in the field. We also provide network solutions from a standpoint of mobile drive-by type applications, AMR, as well as fixed-based AMI solutions that we have been deploying certainly well over about 15 years or so. We're also very focused in the development of software, very sophisticated software for the advanced analytics that are required simply beyond AMI billing, also for some of the other applications of water that I'll speak to in just a little while. We're also a provider of significant services in the industry, everything from endpoint auditing capability, program management in the field. We provide, as Remy had mentioned a few moments ago, I'll talk a little bit more about our managed network services capability and overall program management. From an experience standpoint, we have deployed well over 4,000 reading systems. That number increases every single day throughout predominantly North America. And we've shipped and deployed in the field well over 21 million RF endpoints, the R900 system endpoint that I'll speak to in detail since it was introduced in the late 90s. Fully integrated factory in Tallahassee, Alabama. This is where we manufacture our metrology registers and a lot of the collection equipment. And I'll speak to the R900 endpoint device. I'll speak to its capabilities on the LoRaWAN network here very shortly. And we consider it to be the building block of the smart water solutions of the future. In 2.5 years ago, we actually introduced Neptune 360, which is our next generation of software, cloud-based offering for AMR and AMI. It's a common platform for both AMR and fixed-based AMI. And many of you perhaps on the call may already be migrating from our historical on-premise software applications. So a little bit about Neptune technology. So Ann, about the next one. So I wanted to level set, and we will speak to the AMI side of this predominantly as we go forward, but perhaps for those of you on the call, just to differentiate AMR from AMI. So automatic meter reading, AMR, is predominantly constitutes a mobile walk-by or drive-by type reading system. In the industry and water industry, pretty much began to be deployed in the late 90s or the mid 90s probably, from a standpoint to solve really three key issues, and that's accuracy in billing, the safety issues, and hard to read access, and improving certainly the meter reading process. Typically done here domestically in North America, as well as in using unlicensed frequencies, the 902, 928 unlicensed spectrum. There are some licensed frequencies out there as well, but it is basically a mobile walk-by, drive-by based solution. We're going to focus today on advanced metering infrastructure. And undoubtedly in the water industry, we've seen certainly increased interest on our customers' behalf of advanced metering infrastructure, AMI, which is a true fixed-based AMI meter reading solution. It's really an IoT machine-to-machine based application, no human intervention in actually the reading process. One of the key things I'll bring up is every customer from the smallest to the largest, public to private, is in typically some migration strategy. So one of our mantras here is the evolution of a migration strategy moving forward. One of the key things is we see this is a hybrid architecture very commonly, but a single system that has the capability of seamlessly reading in both mobile as well as fixed-based application. So the key here is wherever you are starting today as a utility is forward guaranteed migratability to AMI and then backwards mobile reading capability if in the event it is required, or in some instances if it is a hybrid application of the same MIU, never having to go back and reprogram that MIU once it's deployed in the field. So a little bit about AMR, it's the mobile walk-by, drive-by, AMI true IoT machine-to-machine, and we see many of our customers currently today in some type of migration strategy towards AMI, or perhaps maybe the end is a hybrid-based architecture. Very key, but the same MIU being deployed in both of these reading scenarios. So a little bit about what we're seeing from a standpoint of the industry and driving, let's say, the market drivers in the industry. Certainly the AMI software and services side of it is driven very much by reduction in non-revenue water, improved efficiencies in the reading process, as well as the distribution system, and certainly enhancement of customer service. Certainly AMR does provide that enhancement as well, but AMI takes that to another level from a standpoint of all the additional enhancements and capabilities of an AMR system. So this is really what we're kind of seeing, a wireless solution of technology that is scalable from the smallest of utilities, and we have some very small utilities, to some of the largest of investor-owned utilities and private utilities. So a wireless solution that has the capability of basically scaling from small to large. Advanced software and analytics for operational efficiency, we see that more and more from a standpoint of an operational tool beyond simply the billing function capability. Additionally, the advanced software and analytics for that, the cloud-based software delivered in a SaaS-based model, we're seeing more and more of the requirements and the need for cloud-based software capability to support both AMR and AMI. Managed network infrastructure, where not every utility has the technical capability or the IT resources to stand up an AMI network. Dave will kind of explain a little bit about that later on, but really we've begun to see managed network services, network as a service, as you may have heard the acronym. Basically, the design, the implementation, and the ongoing O&M associated with for the life of a AMI project, which typically could be 15 to 20 years. And then we're seeing more and more, certainly from a customer's perspective, requirements beyond simply the AMI function to other smart water applications in the potable water side, and perhaps even extensible to the smart city side, IoT machine-to-machine. So these are very much, from a topical standpoint, what we're seeing as far as the drivers for advanced metering infrastructure. We see this in a lot of the RFI and RFPs today. So let's talk a little bit about LoRaWAN just for a second, its attributes and why it's attractive from a standpoint of the water utility industry. There's been a lot of different technologies deployed in roughly the last 20-something years in the field for wireless adoption for meter reading. But if you look at the LoRa technology, it has the attributes of long range, long battery life. The expectation of all customers currently today is a minimally 20-year life expectancy of the endpoint devices in the battery. That's pretty much a stake in the sand. We understand that, and I'll speak to that a little bit further. Low sensor costs. Obviously, the economics associated with driving the sensor costs down obviously allows for the deployment and volume of metering of the endpoint metering and metrology, as well as other sensors. Low bandwidth. The LoRa technology provides for a low bandwidth type application. Most meter reading applications, unless it's data logging or some other ancillary, is not bandwidth intensive. So it's very much optimized towards the IoT machine to machine. A key aspect of this is expected long network life cycle. The expectation by all of our utility customers is a network AMI network being deployed in the field for 15 to 20 years. So LoRa provides that capability of the extensibility of the network for being deployed in a couple different models. Dave will speak to those a little bit later, both public and private, but that is a very key issue with the LoRa technology and the LoRaWAN network. High density connectivity, we'll talk a little bit more about that later. It can be scaled from sparse rural application to certainly urban dense applications for AMI and some of the other applications I'll talk about in just a few minutes. Open standards, development ecosystem, very key. Neptune provides, and we manufacture a lot of metering products, but not all the sensors that are provided or requested in many of the advanced applications that we see from our customers today. So an open standards developer ecosystem is very key from a standpoint of certification for network compatibility and interoperability of all these different sensors, including the metering products on the LoRaWAN networks. And then the last bullet point I'll bring, which is very key, is the Neptune R900 endpoint, as I prefaced earlier, is very key. It provides the capability for network compatibility for the LoRaWAN network, as well as the mobile backup requirement. And all the RFPs we see today all have that capability from an AMI with backup mobile reading. So this is some of the attributes associated with LoRa and the LoRaWAN network that make it very attractive to solve a lot of the challenging issues with water. So next slide, Ann. Okay, so this is an illustration of the Neptune R900 LoRaWAN AMI solution. If you look at it from a topical level, we have endpoint devices that are communicating to a LoRa gateway through a cloud-based architecture back to a host application. If you look at the endpoint devices along the bottom side of this slide, it shows different form factors. We have integrated designs of the meter, the register, and the MIU. We have standalone devices that are actually can be used in a pit environment. The commercial industrial meter that you see there may be a 4-6 inch that is in a vault type application with a standalone MIU with an external pit lid antenna that you see there. And then also we have over on the left-hand side, a little bit further on the left, is actually a different form factor of a wall mount type application that provides the capability of addressing an in-site set application. The LoRa gateway devices could be stood up either on a utility asset. You see the water tank there in the middle. It could be any vertical asset. Height and line of sight is very key. It could be on a commercial site like a cell site, for example, or another radio technologies infrastructure. So the gateways are deployed certainly where it makes sense to provide the broad coverage, and I'll speak to that in a few minutes. Over on the left-hand, and obviously typically the backhaul could either be Ethernet, cellular is very common in a lot of our applications currently today. And over on the left is the Neptune 360 host head-in application. It's a cloud-based platform. It supports AMR, AMI. One of the key things I'll bring to so it provides the advanced analytics, the KPIs, the dashboards, everything associated with the AMI function and some of the other analytic applications I'll speak to shortly. What we're beginning to see also is the trend towards bring your own device in the mobile environment. What you see there is basically, it could be an Android or an iOS based handset or tablet application paired through Bluetooth to some of the mobile collection hardware that we currently provide, our belt clip transceiver, as well as our MRX 920 mobile unit. So this is the higher, if you look at it, this is really the hierarchical architecture of the R900 LoRaWAN AMI solution with the AMR backup. So next slide, Ann. Okay, so this really kind of summarizes that in some sense. Really, it's a standard, we are seeing this more and more, a standards-based architecture with network connectivity for AMI and also other smart water applications I'll speak to in just a few minutes. The LoRaWAN, the R900 and the LoRaWAN network and protocol provide certainly for the broad coverage that's required in some of our customer needs. And I'll explain some of the deployments that we have a little bit later on and show that large disparity between small applications and large. Certainly minimizing the infrastructure, some of the earlier versions of the wireless technology in the industry had a lot of data collectors involved. So this helps minimize that from a standpoint of infrastructure, deployment and costs, and certainly low cost connectivity. The R900 endpoint, as I said, is a key building block with its interleave messaging, its proprietary interleave messaging. It provides outbound messaging for both the mobile as well as fixed-based LoRa AMI messaging from a common MIU for support of fixed base as well as the mobile reading. Very key. The Neptune 360, as I mentioned a moment ago, moving towards a cloud-based platform to support both AMR and AMI, and I'll show some of the applications around that later on. And then the LoRa Alliance, certainly the support from a wide range of water and wastewater applications and sensors for ensuring the network capability and the interoperability. We're seeing more and more from the basic foundation of AMI, which is Neptune's focus predominantly, to certainly other sensor applications being on these LoRaWAN networks. So essentially, next slide, Ann. Okay, so from a standpoint of deployment in the field with our customers, it generally starts with certainly an RFI or an RFP. We work with Neptune from a subcontracting standpoint of the network, our partner. We do the RF propagation study, obviously based on the geocoded data, the GIS data provided from the utility. And it's usually an iterative process to provide the most comprehensive coverage of the installed meter base and to meet the SLOs, basically service level objectives, and the SLAs associated for the data delivery, whether that's data logging, that's interval data, billing data, etc. After that preliminary prop study is done, basically we do the site surveys. We work with Senet to do the site surveys because the modeling is based on certain fundamental assumptions of where these gateway units can be deployed, either on the utilities assets or the municipal assets, or it could be on a third-party commercial. So a lot of times we have to refine that based on doing the site survey. Perhaps maybe that structure is not there. It doesn't provide the height, etc. So obviously this is all about achieving the most comprehensive and optimized network coverage we can to meet our customers' requirements. Considerations, as I mentioned, it could be typically what we're seeing is hybrid, where we deploy the gateway units both on the utility asset or facilities and perhaps maybe on commercial assets. And then essentially the installation, Senet will speak to that in just a few moments, Dave will. And then the last thing is commissioning the Neptune 360 data management system and onboarding the customer through our customer service group based in Tallahassee, Alabama. So this is a very typical scenario, RF propagation study, and then onboarding the customer once the propagation study and the coverage, and we've determined exactly what the deployment plan is with the customer. Next slide, Ann. So a little bit about AMI. I'm assuming that everybody reasonably knows the benefits associated with AMI. It's really all about the granularity and the timeliness of the data through the AMI system, as opposed to perhaps maybe a mobile drive-by, which is a monthly read to bill, or perhaps bi-monthly read to bill, or maybe even quarterly. So AMI provides really real-time data with a granularity to support a lot of the advanced applications. What we're seeing a lot of is in certainly the improved meter operations, leak detection can be used as a drought management tool. Certainly anything for off-cycle reading, a customer service rep can call up the meter when somebody is on the line and resolve that issue immediately. So unscheduled reads or off-cycle reads, typically special reads, disconnect, reconnects, things like that, very common through an AMI-based system. You can resolve customer issues much faster, certainly, and escalate the work orders accordingly. And typically customers become very acclimated, and certainly the utilities customers understand that the resolution and the accuracy of the billing data and the information that is being received if they have a billing dispute, etc. And certainly the enhancement of customer service. we're seeing a lot of requirements. I see this in a lot of the RFPs and RFIs today associated taking that one more level to improve distribution system performance. Things like acoustic sensors for leak detection, focused all around the reduction in non-revenue water applications. DMA studies, load balance audits, things like this, very common being done with the metrology systems and the LoRaWAN network infrastructure for these advanced applications. And certainly optimizing the distribution system, pressure, level, flow, temperature, water quality. These are a lot of the applications we're seeing to be supported in the request for these smart water networks today. Next slide, Ann. And if you can index to the next slide. Okay, thank you very much, appreciate it. So I spoke to Neptune 360 is our cloud-based platform and software offering we introduced a little over about 2.5 years ago. We have a lot of our customers, a lot of our utility customers today transcending and migrating from our legacy on-prem solutions of the past to this cloud-based platform. And really what you see here is the myriad of different applications that are required to be supported from today's AMR and AMI systems. What you see here is just some simple examples, and this is not everything. The data, basically the alarms information, typically out of a register, you can get backflow, no flow, reverse flow type applications. You can get alarm for tamper, things like that. So from the very basic thing, from a standpoint of diagnostics and alarm information out of the meter. Data and diagnostics is very key. Location-based services basically overlay mapping, GIS-based mapping onto this. Obviously, it provides the visualization and presentation to either a field service person or it could be to a customer service rep. And then over on the left-hand side, what you see really is some of the very common advanced applications we see requiring the advanced analytics. So essentially what you see here is really the need for a cloud-based offering as well as web-based presentation and visualization of all the different components, the network, the endpoint devices, the dashboards associated with it, and the focus why most of the software you're probably seeing today in your utility for a plethora of different applications is cloud-based. So this is, we introduced this about 3.5 years, very, very proud of it. It also provides the capability, another key thing, as I mentioned before, we don't make all the different sensors required of our customers today. There are third parties we partner with, and obviously the API integration to Neptune 360 to support these other applications, other endpoint sensing devices. So how about the next slide, Ann? Okay, so a little bit about deployment. I wanted to mention that. So we certainly have seen significant traction here domestically in deploying these systems. We've been deploying them a little over about 2.5 years now. And what I'll do is give just some profiles of the typical customers. We've seen customers that have deployed fully AMI systems that are very small. These could be small towns, for example. We're seeing certainly a lot of customers that are in that medium to large municipality, county water operations, both water districts. We've seen and deployed AMI systems as small as service territories below basically 9 square miles. And we're actually in deployment and beginning deployment under contract, some opportunities that are well above 600 square miles. So it shows the scalability and extensibility of the solution from very small applications to certainly large service territories. So that could be rural to suburban service territories. What we've seen is anything from below 5,000 meters to seeing several applications which will be extendable beyond 50,000 points or more in a multi-year phased deployment of a lot of our customers. They could be from direct read directly to AMI. They could be hybrid direct read and mobile AMR to AMI, just depends on where they are today. We've seen a lot of pilots, 6-month pilots, and then those turning successfully into multi-year phase deployments. Most of what we deployed today thus far has been PIT-based applications and standalone MIU applications as well with external PIT lid. We do have some projects that will ensue with the standalone wall-based unit for some inside set applications. And unquestionably, the escalation in the RFI and the RFP process. We are responding to RFPs and RFIs every week today. So essentially with that, what I want to do is we'll pass it on to Dave. He's going to talk a little about the LoRaWAN network deployment, and then I think at the end we'll open it up to Q&A. So I'll pass it on to you, Dave.
Thank you very much, Bob. And thank you everyone for joining our webinar today. As Bob suggested, we're going to talk about the network side of this and go through that in some detail. A little bit of background about myself and Senet, the company that I work for. So I'm the Chief Technology Officer and Chief Operating Officer at Senet, and have been with the company since we began investigating low power wide area networking technologies in 2014. We are founding members of the LoRa Alliance and actually began deploying our public networks just before the LoRa Alliance was officially founded in 2015 at Mobile World Congress. In addition to that, I'm also a newly elected board member of the LoRa Alliance and currently chair the Regional Parameters Working Group within the LoRa Alliance. Senet is a public network operator. That's what we're most well known for, I would say. But in addition to that, we are also a core technology provider of LoRaWAN networking services, OSS and BSS capabilities. At one point in time, we manufactured gateways. We no longer do that. We work with all the third-party gateways on the market today. And at one point in time, we actually had an IoT solution, one of the first LoRaWAN solutions for propane tank monitoring. In addition to those core technologies, the other thing that makes us unique is that we have a very innovative approach to the market and to building networks in this space, a very cooperative approach. We call that the LVN, the Low Power Wide Area Virtual Network. And this enables us to interconnect networks that would otherwise be islands of connectivity together, whether those are deployed by Senet, by our operator customers, or by application providers, which is what we would consider Neptune, or by dedicated partners who are only deploying the physical networks themselves and delegating the management back to Senet. If we can go to the next slide. A little bit about LoRaWAN from our perspective. Back in 2014, we investigated all of the different low power wide area technologies, the nascent technologies at the time, and selected LoRaWAN really for a couple of key reasons. On the technical side, it addressed the widest variety of use cases. The ability to support bidirectional communications enables us to do things like firmware upgrades over the air. It enables us to do not just data gathering, but also command and control back to devices, maybe closing a valve. In addition to that, it was very low cost. Low cost is really defined in multiple dimensions. One of them certainly is the chipsets, the overall complexity of the end devices, but also the coverage that you get out of this radio technology that enables us to build very cost-effective networks as well. In addition to those technical capabilities, there was a high-level market approach as well that was very important. And that really was the foundation of the LoRa Alliance. This open ecosystem, this open alliance that was built in order to create a standard that would be able to enable all these end devices, all the network operators, the gateways, to interoperate with each other wherever they existed throughout the world. And that was the other key component, and one that we think is still a very, very important element of what we're doing. As Remy mentioned at the beginning, the ecosystem is growing by leaps and bounds, one of the fastest growing technology alliances in history. And it continues to grow today with all different kinds of companies, large, well-established players, brand new startups, and everything in between. So if we can go to the next slide, in the LoRaWAN, as it applies to the utility space, I think is very, very interesting. There's a couple of elements here that are important to touch on. So one of them, as Bob mentioned, was this ability to provide connectivity in extraordinarily difficult RF conditions. So the capability to build a device that will last 20 years or more, and to be able to commit to a technology as a network operator that you're convinced will last, those 20 years as well, are key components to addressing the utility space. Those capabilities are not present in really any of the other technologies that you see out there in the market today. The pace of change in 3GPP networks is extraordinarily fast. The commitment to some of these they would consider smaller market segments of massive scale IoT is yet to be tested, where we have an entire ecosystem here that's completely focused on that. In addition, the way that the standard was created and the architecture behind that standard also enables companies like Senet and Neptune and others to address the connectivity problem in many different ways. So that can be kind of in the traditional public network as a service way, where Senet or another operator comes in and overbuilds an area with network, and you connect up to that without any further consideration. Or it might be that it's better, more effective, more cost effective to address that with a utility owned and operated network or municipal network. All of these things are important to being able to deliver the ultimate low cost guarantees that we're looking to achieve here. And even more importantly is the ability to bring these multiple models together and provide a seamless set of connectivity with both public network opportunities, utility-owned operated networks, as well as hybrids between the both of them. And in many of the networks that we build in conjunction with Neptune and their deployments, it is exactly that hybrid that we're looking for. If we can move to the next slide, please. So, with that kind of background established, we're going to talk about 4 different stages that we go through in terms of deploying a LoRaWAN network for utility deployment, for water metering deployment. We're going to talk about design, acquisition, which is the kind of lead up to the construction phase, and then finally the verification. So if we can go to slide 21, please. The next slide. So we'll start off with the inputs to the design process. So when we do a network design, we're really looking at gathering information from our customer, which in this case would be Neptune, and in turn is gathering it from their customer, which is the utility. This starts with the list of geocoded service addresses, all the end devices that we're looking to provide coverage to. It also, in many cases, will contain a list of assets that the utility or the municipality will make available for network deployments in these cases. And then finally, the specifics around both the end device characteristics. So, what kind of device is it? What kind of transmit power does it have? Antenna characteristics? What kind of data is it going to require to the network? As well as installation details. So in the case of the water utilities, is this a pit meter, so mounted underground, as Bob said, maybe with a through the lid antenna, or is it a wall mounted meter, where it's going to be mounted maybe at closer to a meter high with nice, much nicer RF conditions? All of these factor into the network design process. I do want to pause real quickly here and just let you know that the images are a little blurry on purpose to protect the confidentiality of the end customers. But these are definitely representations of live designs that we have, and hopefully you can get the idea. So if we move to the next part of the design practice, once we have those inputs, we now generate a multi-step process to actually determine where we're going to deploy network and what service addresses will be covered by that network. We start with a path quality analysis. This is part of the tool set that comes out of our OSS and BSS system that we've developed ourselves. And this enables us to very rapidly get an understanding of which assets, whether those are commercial towers or in this case, water tanks or pump stations that may be available to put networks on, which ones of those are the optimal ones. It lets us iterate through this process with the acquisition side, which is actually going out, doing negotiation and various other things to find out which assets are available and reasonable to use. Once we've gone through that process, we then do a propagation study using typically two-dimensional modeling in most of these cases, where we're actually building not just the path quality, but the actual link budget associated with each of those locations that are asked to be covered. At this point, this turns into our output back to Neptune, who uses that as part of their statement of work to the utility. So once we've gone through this process and we've agreed around the network and the coverage that's going to be provided, we move on to acquisition. So acquisition is the part of the, and if we can go to the next slide, please. So acquisition is the part of the process where we are negotiating with tower companies. This will be things like lease, availability, what kind of zoning and permitting is required, or structural analysis required, what's the rent going to be, the availability of things like power and backhaul. And we do the same thing with utility or municipal assets as well to understand what else is there. Are we going to be able to have a clear view? Is there already power? Do we have to trench power? Do we have to provide our own backhaul? Is there backhaul that we can use? Going through this process, I said, kind of getting a sense now, a very refined sense of what the budget is going to be associated with each one of those sites. And again, we're probably iterating through this stage, going back to the design phase as we have to. When we complete this, we get a notice to proceed. So the notice to proceed is what we hand over to the construction companies. So if we can move to the next slide. On the construction side, now this is from Senet's perspective, we always do this third-party outsource. So we are going to do site visits, construction planning. We are going to verify that the sites are as advertised. Shockingly enough, that's not always the case. Validate that the backhaul is available, that cellular performance is good. We'll do spectral analysis scans of those locations to make sure that there aren't any interferers that were not already documented and taken into account. There were some questions about this part of it. So we see in the utility space specifically, there is a fair amount of 900 megahertz solutions that have been deployed out there, and specifically in the water utility case, we see a lot of SCADA systems. We would typically characterize these as legacy systems, so they typically are being phased out in favor of higher bandwidth alternatives. But we are able to take that into account, and we still deploy on sites that have SCADA backhauls mounted directly on them at 900 megahertz. Finally, after the site's validated, we prepare the equipment is shipped, it's ground tested, and it's installed. While it's installed, we are going to do an on-site validation. So while the climber is still on the tower, we're going to make sure that everything is continuing to work as planned. One of the things, just for a sense of magnitude here, is that the gateway itself, relative to other communications equipment, is a relatively small percentage of the overall cost of installing a site and maintaining a site over time. And from a climber's perspective, it's a very small piece of gear. So it's not massive sectoral array antennas that need to be winched up. This can be put in a climber's pouch, and he can climb with it right to the top of the tower. Okay, once we've completed construction, we'll move on to verification in the next slide. So verification is validating that the installation went as planned. So we require closeout documentation, photos, local contact information. How do we get access to the site in future? Any specifics associated with the ground facilities, as well as the tower facilities or structured facilities that are there. We'll do on-air performance validation, coordinated with our network operations center, kind of a basic functional test of all of the equipment. And then there's an optional phase depending upon the kind of network that we're deploying and what its purposes are, and that will include an RF acceptance test where we'll go through and do drive testing of selected coverage areas with end devices which model the behavior of the device and the applications that we're providing coverage to. In some cases, we'll actually take the actual devices that are being deployed and we will validate their behavior at selected locations in those areas. The little graphic on the left-hand side of the screen here is a pictorial representation of that being done against the network we have in New York City. Doing some, we usually call it drive testing in New York City. It's actually faster to do it walking, so it's walk testing here to validate the coverage is as it was intended to be. All right, so we've now completed the physical part of the network installation and validation. So as we move on to solutions monitoring, now the network is up and running. Now we're going to be making sure that it's being monitored 24/7. So we're looking at all of the relevant characteristics. We're looking at kind of 3 areas of performance here. So the core interconnect performance, that's the connection between our core network and the Neptune 360 platform. So this is critically important. So we're monitoring the behavior of that northbound interface. We're looking at performance metrics. Is a round trip time acceptable? Are we seeing errors? Are we seeing discards? What kinds of errors are we seeing? As well as looking at the internal performance metrics that we have of our core network itself, which is a fully cloud native platform. The radio access network, that's what RAN stands for, if I haven't said it before. So radio access network performance. So this is the gateways. So what kind of interference are we seeing? What's the capacity loading of the gateway? How is the backhaul performing? All of these things are critical aspects of the physical side of the network. So there were some questions about interference and what can be done and how does this work. As I mentioned, the LoRa technology is very is very strong in the presence of in-band interferers as well as sideband interferers. But we have the tools here to be able to look at the performance of that network and identify specific areas where interference maybe is causing a problem. So the graphic on the far left is a heat map of the RF performance of that gateway. So once that's there, we can selectively disable specific channels that may be particularly susceptible to interference in that space. And I'll go back to the SCADA comment I made before. So with SCADA systems, and most of the spoke side of the SCADA system, they're using a relatively narrow portion of the ISM band. So if that's the case, we can easily carve that out and prevent the devices from using those portions of the band. And then finally, we're looking at end device performance. So in massive scale IoT, we're not looking at an individual meter's performance typically. We are looking at population trends. So what is the fleet behavior here? Are we seeing areas where performance is not what we expect it to be given the coverage commitments that were made? Are we seeing things that might indicate that the meters or the devices were mislocated during the installation process? So we thought this meter went here, but it really went over here. Or maybe that we've seen something that indicates damage happened, something damaged the installation, the meter installation. So it was working fine, and now it's not working well anymore. All of these can generate alerts and behaviors that we can use to ultimately triage the network. And of course, the tool set provides both the visual tools that you see here as well, of course, in massive scale IoT, alarms that trigger on those key indicators. So if we move to the next slide. The beautiful thing here about LoRaWAN networks is that even though this network was deployed for an AMI use case, it has the ability to support an enormous range of applications from devices that are compliant with the LoRaWAN standard for almost anything imaginable. So this can start certainly with other utility applications. So as Bob mentioned, so that might be some water infrastructure monitoring that's going to be going on. Maybe it's the wastewater plant, or maybe it's groundwater. But you can also look at other kinds of utility applications. Maybe you want to do pole monitoring for electric poles, or line break monitoring, arc detection. Maybe there's gas applications that you can apply to this. The networks that we're building for the water metering use case are among the most capable networks that are out there. So the water metering use case is a very challenging one. As I said, most of these installations are below grade, very challenging environments. So this networks can easily support these other applications. One of the questions that gets asked very frequently is, well, what is the capacity loading of the gateway of the network once the water metering networks are fully deployed against it? So the models that we use show that this is typically between 1 or 2% of the capacity of the network, even with networks that may have 100,000, 200,000, 300,000 metering endpoints underneath them. This is a very, very conservative approach. So as the operator, we're always conservative with these things. So this isn't a theoretical limit. The theoretical limit is probably 10 times higher than our operational model that we use for this. So in addition to the utility use cases, there's a whole adjacent space here that's extremely interesting, and we think this is how smart cities will really ultimately be developed. So it starts with the utility, and then it moves an application at a time to those very interesting smart city applications: leak detection, air quality, smart lighting, all those things. So one final slide, and then I will wrap up. And really what I wanted to kind of focus on is that the power of LoRaWAN and the power of the utility use case, the metering use case, is that it enables us to bring together all of these different partners and capabilities to deploy, the widest range of possible IoT solutions. On the top side, there's all these different applications. All of these compliant LoRaWAN applications can work seamlessly together. And on the bottom side, we have all the network participants of all the different flavors: the utility, the municipalities, Senet, the network operator, tower companies, even enterprise applications that are deploying a smart building use case or a smart factory use case can all be brought together and provide ubiquitous complete coverage for fantastic massive scale IoT applications. And with that, I think I've run through my time, and I would like to turn it back over to Remy for closing thoughts, and then I think finally for Q&A.
Sorry, I wanted to thank you, our panelists, Bob and Dave, for this very good presentation. It was very powerful to develop the topic. Nevertheless, we will have questions. Before that, just to highlight that by December 3rd and 4th in Paris will be the LoRaWAN World Expo. This is the 5th anniversary of the LoRa Alliance. And for that special occasion, over 2 days, will be presented many different solutions with both of enterprises and associations, and different panels in conferences. So be sure you book the dates in your agenda, and we will be very happy to see you there. Now let's kickstart the Q&A. You have delivered already the attendees, you have delivered already more than 22 questions. Already some have been answered, and I have also my questions, so that's a privilege. I will just fire this up with a question for you, Dave, regarding the design of networks. What is the most challenging aspect of designing networks for the utility applications? Dave, you're unmuted.
Sorry, thank you. Occupational hazard. So I think there's two things. So one of them, as I mentioned, was the extraordinarily challenging RF environment, coupled with the knowledge that certainly our partner Neptune and the utility are expecting carrier grade performance out of this. So it means that you have to take a very conservative approach to how those networks get built, to make sure that there's redundancy, to make sure that there's sufficient coverage, and that the overall solution is going to meet those very demanding SLAs and meet them for a very, very long period of time.
Can you indicate, for example, what is redundancy you're trying to achieve every time you deploy network?
So it varies by application, but in the utility use case like this, we're looking for at least full redundancy. So we're looking for any given gateway going down, not stranding devices without coverage. And again, in the networks that we are deploying right now, we see that is very often the case. So we're really shooting for that. It's not 100% of the time. At the fringe areas of the network, sometimes that's challenging, but in general, that's what we're looking for. And that changes how the network looks. So if you're deploying for a very simple, sparse outdoor use case, I mentioned we did tank monitoring for heating fuels before. We might plant a gateway every 15 or 20 or 25 kilometers. And when we're doing that for a utility application like this, we're probably more like every 5 kilometers, that we're planting a gateway, 5 to maybe 10 at the stretch.
Thank you. And to continue with that topic of challenges for deployment, Bob, the question for you is, in your experience, what are the most important challenges for AMI deployment in North America? And how the LoRaWAN offering with network as a service is positioned in importance against other factors?
Okay, all right. Essentially, I guess when I look at any AMI deployment, There's typically three things that are the key challenges. That is the business case to be made to migrate or to move to AMI. Obviously, the value add has to be conveyed to upper management so budgets and funds can be allocated accordingly. The other key issue is certainly the back office integration into the enterprise applications, whether that be billing, customer care, and support applications or other applications, advanced applications that I spoke to for distribution management applications. Obviously key, and this has been one of the key challenges throughout when the first AMI systems began to be deployed in water back in probably the early 2000s, was really the overall RF network infrastructure. And that was the key thing. Most of them were all proprietary, purpose-built, essentially. And so really, if I speak to the LoRaWAN network and the NAS side of it, I think it's probably at parity to the other two key areas, the overall network architecture, the deployment of the AMI system. As I mentioned previously, many of our customers currently today are considering NAS because they do not have either the technical expertise, the radio expertise, or the IT resources to be able to stand up an AMI network. So I'd say those are really kind of the three key areas: the business case, back office legacy, enterprise applications integration, and certainly the LoRaWAN network deployment. I think they're all somewhat at parity. Those are the three key things I think that any utility is looking to deploy AMI has to solve and resolve those issues.
Thank you, Bob. So now the attendees have pending questions. We will take a bit in the order. I can see most of the questions are very oriented for practical learnings, the best practices, etc., and also some technical questions. Which is good, and perhaps we will trigger a second webinar. But let's try to tackle these questions. The first one is for you, Rob, about some metrics regarding addressable market size for smart water metering.
Okay, I think I saw that actually, and it's very hard to address. Obviously here in the US, North America, is the installed utility meter base is in the 90 millions of endpoint devices. As I said, and I hope I conveyed this earlier, is we look at any of our customers currently today with the R900 as a building block, that any customer currently today that is deploying AMR mobile drive-by today or walk-by has the opportunity to move it to an AMI-based solution. In most manufacturers today, obviously, that is a key focus to provide that migration strategy. I don't know the exact addressable market. There is more than 55,000 municipal entities in the United States currently today. That's in the US only. So that can be from very small town with less than 2,000 meters to certainly large investor-owned utilities. It's very hard to put a specific number on the AMR addressable versus AMI. We look at every customer of Neptune's as having the potential to migrate from a mobile to an AMI solution at their will, at their pace. That's really the key issue. They determine the migration strategy, not us. So it's very hard to kind of put a statistic that it says it's 90-10 or it's 50-50. We really can't do that.
All right. Regarding the total market size for smart water metering, I have seen a number previously in a market analysis report from IHS about in the range of 8 million for new shipments per year. Is that some kind of a figure you're familiar with?
Well, I've seen some of the IHS reports before. You know, there are a lot of reports that indicate the market opportunities. You know, we subscribe and we do have some of those reports as well. We certainly have our forecasts that we look at from our customer base, but I would suggest that, you know, every week and every month we're seeing more and more RFPs. Some of those unbeknownst to us, and some of those are expected for AMI deployments. So I can't say specifically that number, but I can tell you very clearly that the RFP and RFI exercises that we're seeing today are unprecedented compared to what they were 10 years ago, or more than a decade for AMI. No doubt about it.
Yeah, I keep you again for another question about, do you have knowledge about the largest R900 LoRa network deployed?
We have deployed, currently today, we've deployed a system that is roughly about 17,000 points fully deployed. I can't remember the exact number of gateways with Senet. That one has completed after a 6-month pilot in roughly about 18 months. As I mentioned previously, we have several projects under contract where we have begun to deploy in that 15 to perhaps maybe 40-something thousand meters. And then obviously, so that's kind of the key focus today. And we've also deployed a small system that's less than 5,000 units. But we are in deployment of probably about 10 to 12 different systems right now.
Yeah.
That's probably
to continue with your product, there was a question, I think you said it already, it's an ultrasonic water meter, correct?
I didn't get, what was the question?
The question is it only available with mechanical meters or ultrasonic too?
No, as I mentioned in that illustration of the drawing, no, all of our R900 technology is for PD-based meters as well as our ultrasonic meters, yes. So we can support ultrasonic as well as positive displacement, yes.
So Dave, now you answered already some question about the traffic that LoRaWAN gateway can support, and you shared this indication of 1 to 2%. But could you say a bit more about the characterization of network capacity and coverage that you're handling?
Sure. You know, there's a few questions on this topic. So, you know, there's theoretical numbers. So, theoretical numbers from a gateway perspective, an individual gateway perspective, are typically you're looking for a typical LoRaWAN application. So everything is kind of needs to be measured against kind of something. So a typical LoRaWAN application is probably uplinking, you know, once an hour, you know, several times a day, those sorts of things. You can typically see on one of the larger gateways that you're supporting, you know, well over 1 million or more end devices on that individual gateway. Practical application, though, we have to take a couple of things into account. So the first is that when you deploy mini gateways over an area, those gateways will be hearing the same transmissions from an end device. So as I said, we're designing for redundancy intentionally. So we're definitely not, even though the gateway is receiving, you know, can receive maybe as much as, you know, nearly 100 million transactions a day. Those are not all unique and distinct. They will be redundant and shared with other gateways. So as we start factoring those capabilities in, we start looking typically, you know, that we're at the hundreds of thousands of practical end devices deployed per gateway is the theoretical limit. From a financial modeling perspective, we typically use a metric of somewhere around 50,000 devices per gateway, where even though we're not near capacity, we're going to put another gateway in as well. And that's going to, you know, with the capabilities of LoRaWAN, that will reduce the RF footprint, if you will, of the end devices. We'll turn down the spreading factor, we will turn down the power, and we'll get more and more density. So this is one of the amazing things about LoRaWAN, is that you can dynamically move from coverage-based networks to capacity-driven networks, you know, very, very seamlessly. There's no change on the end devices, there's no change in the gateways, it's all done in the core.
Yeah, I mean, just that we are getting a bit after the finite timing. Just to finish with a question, what is your expectation in terms of evolution? You already shared that many RFP and RFPs are requesting solution for AMI. This is a key trend. You have a value proposal. You have a capacity to expand and support other applications, like you presented about smart cities. So what is your expectation to continue further and I would say create even more successful adoption in North America?
Is that question to me, Remy, or to Bob?
To you both.
Well, I can start since I grabbed the floor already.
Go ahead, start, then I'll answer.
So we really think that this is we're at a turning point now. So we're in full production with utilities. And this is the foundation by which we can go after, again, as an ecosystem, go after these additional use cases and applications that are really going to be instrumental. So I think in the past, regardless of the technology, smart city applications have always struggled because it started with the assumption that you needed everything in order to justify the ROI. And what we can do now with utility focused as the first step is that the utility has a self-contained business model. These guys have been selling meters for a long time and AMI systems for a long time, so it's well understood. And once that's in place, now it opens up the opportunity to go in with these other applications that by themselves probably were not worth pursuing, but now can be pursued very, very easily. So if you look at something like a utility or a municipality wants to track its, municipal vehicles, for example, that can be done now on top of these networks. And because these networks are as dense as they are for the utility application, they support virtually every other kind of application that exists, whether that's deep indoor penetration. We had some questions there, is deep indoor, underground. The meters are effectively underground in the pits. We've done deployments in basements with our oil tank monitoring solution, and LoRaWAN works great in those environments. And the networks that we're building are going to be able to support those kinds of applications.
Yeah, and you, Bob, what do you expect for development of the ecosystem and the adoption of LoRaWAN with your solution?
No, absolutely. I think, being involved with certainly the AMI side of it for well over a couple of decades, we're seeing, and we state to this, is basically a smart water network will support the AMI functionality, as Dave has talked about, as well as many of the other ancillary surrounding applications for IoT machine-to-machine. Distribution management applications. Historically, the utilities, regardless of its electric, water, gas, have had different silos of different network technologies for mobile communications, data communications, for basically meter reading applications. And I think they're looking at it more from a holistic, let's leverage some network architecture for all these different applications. Now, I will tell you, we see a lot of requests for smart city support from that standpoint. Well, what defines smart city? Is that smart parking? Is that smart lighting? All of these other things. Our focus, I will tell you, within Neptune currently today is really about the potable water and all those other ancillary advanced applications I spoke about in distribution management, as well as potentially some things I would easily see, because a lot of our customers are also, they may be providers of potable water as well as wastewater collection. So that's really our primary focus. But I concur with what Dave said. We look at this, the water industry is a very challenging industry from an applications perspective. And if we can stand up networks with plenty of capacity and the coverage provided by LoRaWAN, we're going to see all kinds of other sensor applications being stood up on these networks. And we're seeing that. We are definitely seeing that.
Thank you. So I think it's time already passed by 7 minutes. So we are now closing the webinar. I want again to give a warm applause with, of course, social distanciation that we have to respect, to our great panelists. Thank you, Bob. Thank you, Dave, for this very outstanding presentation. All the questions that have not been answered will be managed in text way and will be shared via the website of the LoRa Alliance. A request for more information about like LoRaWAN World Expo are available on the LoRa-alliance.org. We will communicate that information to attendees. So thank you again. There will be other webinars, great topics to be discussed about still utilities with DLMS on June 2, and another webinar about smart utilities, but in Europe, on June 25th. More to know, white paper also coming out soon with use case of Neptune and Senet and more. Thanks again to everybody.
Thank you.
Thank you.